Hey everyone, we're back today talking still about lines and their equations, but today we're going to talk about inequalities and how to graph those on a coordinate plane. So again, this is something that we've talked about in Algebra 1, but we're going to review it today. There's two things that you really have to know for this. If it says y is greater than, you're going to shade above the line or above the y-axis. Whereas if it says y is less than, that's when you shade below the line or below the y-axis. That's the first thing. And the other thing you have to know is that you use a dotted line if it just says less than or greater than, a solid line if it also has or equal to. Let me give you an example. It says graph x plus 4y is greater than 2 on the coordinate plane given below. This inequality is in standard form right now. So far we've mentioned point slope form and slope intercept form. This is a different form called standard form. You don't need to worry too much about it, but it's that form ax plus by equals c, just so you recognize it. That would be great. But we want to switch it over to slope intercept form. We've done this already with switching from point slope to slope intercept, and it's going to be the same thing. You just have to get y by itself. So here's our inequality. If we want to try to get y by itself, the first step would be to move the x to the other side. When you subtract the x over, I'm going to put it as the first term because then it's more like the y equals mx plus b format that we're looking for. The next step to get y by itself is to divide every term by 4. Keep in mind that if you are dividing by a negative number here, you would have to flip the sign. 4 is just positive in this case, so we're going to keep it as y is greater than. In order to figure out the slope, you're going to put whatever the coefficient of the x is over 4. So we're going to put negative 1 over 4, then put the x. Bring down the plus, and then do 2 over 4, reduce that to get 1/2. Now that it's in slope-intercept form, it'll be very easy to graph. You can easily tell the slope is negative 1 over 4, and the intercept is 1/2. So when you're trying to graph that, you always start with the intercept. So you're going to start at the point 0, 1/2. So the x is 0, the y is 1/2. Because that's the y-intercept. Remember that y-intercept is always where x is 0. The slope is negative 1 over 4. What that tells us on the graph is to go down 1, right 4. I always go to the right, and I let the positive or negative tell me whether I should be moving up or down. So it tells me start at 0, 1/2. So x is 0, as a reminder, the x-axis is this one. So I'm going to go to 0 on the x-axis, 1/2 on the y-axis. Put a point. Then from that point, I go down 1, right 4. So I should have another point at 4, negative 1/2. And I could keep following that straight line pattern. That's the good thing about lines, is that it always has the same slope. Now, in order to get some more points on the left side of my graph, instead of going down 1, left 4, that wouldn't make a straight line. So instead, I have to flip that and go up 1, left 4. That way, I'm still following the pattern of the straight line. So I should have 2 more points, one of them at negative 4, 1.5, and one of them at negative 8, 2.5. If I go any further, I'm going to go off the graph, so I'll stop there. Next, look at the inequality symbol. It says that y is greater than the equation, so I know I should make this a dotted line. And I know that I should be shading above that y-intercept. This one's pretty easy to tell what's above or below the line, but just to point out, if you weren't sure what was above the line or below the line, you can look at your y-intercept, shade above that on the y-axis, and then say, okay, I know I have to shade everything on this side of the line. So now I'm going to go back and shade everything that's on that side of the line. So you can highlight it to make it clear, these are all the points that are shaded. Another way, if you're not quite sure which way to shade, is to use a test point. Here's what that would look like. You can pick any point. Let's just pick this point 0, 10. So my x is 0, my y is 10. If I plug in 0 for x and 10 for y into my inequality, does it make it true or false? So I'm going to put 0 for x, 10 for y. You have to multiply before you add. So you do 0 plus 40 is greater than 2. Is 40 greater than 2? Yes. So since that's true, it means it should be shaded over. So if your test point comes out to be true, it means it should be shaded. Whoops, I tested 0, 10, not 0, 0. So 0, 10 should be shaded. Any point that makes the inequality true should be shaded. Let's see what happens when we plug in a point that's not shaded, such as 0, negative 10. If I plug in 0 for x and negative 10 for y, I end up with negative 40 is greater than 2. That's a false statement, so it doesn't get shaded. This is telling me that all the points that are shaded will make the inequality true. All the points that are not shaded will make the inequality false. What about the points on the line? Let's check this y-intercept, 0, 1/2. If you plug in 0 for x and 1/2 for y, you get half of 4, which is 2. 2 plus 0 is 2. Is 2 greater than 2? No. So this is a special case where you end up with the same number on both sides. And in this case, it's false because 2 is not greater than 2. Because it doesn't have an equal sign under it. That's why we had to use a dotted line. So dotted line tells us that the points that are actually touching that line will make the inequality false. When you're solving these problems and they just say to graph it on the coordinate plane, like in the practice problem, you don't actually have to go through and test all those points and put them on the graph. I just wanted to get you to understand that the points that are shaded over make the inequality true. The points that are not shaded over make it false. Here's the correct answer for that practice problem. You can check it whenever you're ready. Feel free to pause the video. And when you're finished, that's all I have for you today. In the future lessons coming up this chapter, we're still talking about linear equations. However, we're going to put multiple equations together and create a system of equations. You may or may not remember what that is, but we'll review it together soon. See you then. Bye.